The honest truth is a lot of the people who are on production lines today have a lot of experience, and they've been in the business for a very long time. And when you ask me that question, one thing that sticks out to me is we just as humans run on autopilot, and people just like have done this over and over and over and over and over again. I remember someone on the floor told me I can close my eyes and run this equipment backwards. So it's like they have so much experience. And so that can be a great thing, but it can be also a very dangerous thing, considering how delicate what we're working with is.
That's my guest, Indium's Kay Parker, next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
My guest today is Kay Parker. She is a technical support engineer based at Indium Corporation's headquarters in Clinton, New York. She provides guidance and recommendations to customers related to process steps, equipment, techniques, and materials. She's also responsible for servicing the company's existing accounts and retaining new business. Kay first joined Indium Corporation as a college intern. I know Indium enough to know that they have a pretty aggressive intern program. They have lots of interns that come through there, and many of them make their way, as Kay did, to employees. After graduating from State University of New York Polytechnic, also known as Sunny Poly, I love that name, in 2018, Kay joined the company as a technical support engineer. Kay has a bachelor's in applied mathematics with a minor in engineering science. And she did many things in college, and one of those things was she helped form and lead an award-winning competitive student robotics club. I could just geek out all day on that concept. And she also worked on modeling the flow of blood in the human eye using mathematical equations and computer programs, which is that's probably a very interesting conversation just on its own. So welcome, Kay Parker. Thanks for being my guest today.
Thank you, Mike. Thank you for having me today.
Of course. Now, Kay, one of the things I was excited about when you agreed to be my guest on this program is that, unlike pretty much every other guest that I've had, you're newer to this industry. You graduated university in 2018 and joined Indium, and I'm assuming this is your first job in our industry, in the electronic assembly industry. Most of the guests I've had have been around for 20, 30, sometimes more years, which is always a very interesting conversation because they have all the horror stories from the past. They know where all the skeletons are buried. They've seen new technologies come and fail and or be successful. So they have a lot of experience and a lot of history. And I know in my career, the experience and the history is very beneficial, but it could also be very limiting because a lot of times my younger staff will come up to me and go, "Hey, Mike, we have this idea." And I'll say, "Well, we tried that 25 years ago. It didn't work. Move on." and they sometimes persist at it. And then I realize that, yeah, actually that is a good idea. We didn't look at it that way then, or we didn't have the supporting technology then. Now we do. So it's nice to speak with someone, particularly in our industry, that has a fresh set of eyes and does not rely on old, maybe even antiquated or obsolete experiences to apply to the possible technologies that are available to us today. So I remember when I was very young, before I was in this industry, my father purchased a small family business, and it was a small printing company, a quick printer, back in the days when we actually printed things on printing presses and not digitally. And he stayed at his day job, and I ran the company for him. And I remember someone came in. I knew nothing about that industry, absolutely zero. I had no training. I did not get any informal or formal education on the subject of printing. I just learned it day by day. And I was running the front desk and someone came in and wanted a particular type of job. They wanted to be able to print 2-color on coated stock, shiny paper. And I'm like, sure. And I went to the back where our printer was and asked the fellow back there, where do I find information on this process and how much do I charge? And he said, no, we can't do that. I'm like, really? And he goes, yeah, we just can't do it. I'm like, how come? And he says, well, we just can't. We've never been able to do that. I'm like, well, okay. Yeah, you know better. You've been around a long time. So I went back and I told this customer, sorry, we can't do it. And he was disappointed. And then he told me he wanted like 10,000 or it could have been 1 million. Who knows? He wanted a lot of this product. We could have made so much money on it. And we turned it down because I was told, well, we can't do it. Well, that bugged me. And I was new and naive and totally inexperienced. So I wanted to know if we're going to turn down business, I want to know why and figure out, well, what will it take for us to not turn down that business? So I read up all the manuals. There was no internet back then. So I read up all the manuals on the presses that we had and some books that on the subject. And I went in one night and just started experimenting. And I found some old equipment up in the attic that was required to do what this particular customer wanted to do. And long story short, we could do it. We could totally do it. And then when I confronted the employee like the next day, he goes, well, I was told we couldn't do it. Well, it turned out it was a multi-generational family business that my father had purchased. And it had been at least 2 generations in another family. And someone someday just made a decision back in 1940 or something. Oh yeah, we can't do this. And that was probably based on, we don't want to do it. It's a pain. It's a dirtier process and you really have to know what you're doing. And so they just said no. And then the legend grew. And then it went from we don't want to do it to we don't do it to we can't do it. And it came to me and I just drank the Kool-Aid and said, yeah, we can't do it. And then when I went and asked the questions, it turned out it wasn't can't. It was totally can with certain caveats. So I would imagine in any person's experience when they come into, when they leave university and they jump into the workplace, they jump into the deep end of the pool, so to speak, there are people around you that will, like my old printer would go, no, we can't do that. And it's really the unique ability of someone brand new in an industry to ask those questions like, why not? How come? Like a little child asks, why? And sometimes the answer may have been accurate 20 years ago, but it's not necessarily accurate today. It's no longer accurate. Right. So I think
it's very true.
Yeah, I hope that's true. That was my experience, and you're also validating that's you agree with that, so you probably see that too. And I think that really benefits any company to have a good mixture of the experienced sages, the crotchety people in the corner that say yes or no to things, and based on all this experience, I think that's valuable. I'm not discounting that at all. I think it's also just as valuable to have someone who's a little naive and doesn't understand why no is an answer and needs to see it for themselves. And maybe they see something differently. Maybe they see something that 60 years ago people never saw, or maybe the vision today is based on modern technologies and support technologies that make that decision possible, where it wasn't possible when the original decision was made. So I think there's a good mixture. We can't have everyone new, or we'd be doing, we'd be doing everything, off the deep end.
Backwards.
Yeah, but we can't have everyone old either, because then, we never improve, and we don't embrace new technologies and new ideas and radical ideas. So I think it's a mixture of both. And what's worried me, and I've said this in other episodes, what's worried me about this industry is it was really getting to the point where it was gentrifying. It was just becoming an old person's industry in general. And not a lot of young people were coming into the industry. And that's changing. I'm seeing that there are way more younger people like yourself entering this business of equal genders, which is also quite amazing, because I think men and women think differently and they have different analytical mindsets. And to have a mixture of men and women experienced and inexperienced is like the nirvana of the right balance of talent to bring in. So I am seeing now an introduction of younger talent coming into the industry, which makes me feel better for the next 10 years. It's not going to be just old crotchety guys like me. It's going to be people who think differently about thinking differently. So I'm glad
I agree with you on that. Mm-hmm.
Yeah, I'm glad you see that. So let's talk about a little bit about your expertise. When I reached out to my friend at Indium and said, hey, I want to get someone for the podcast, he gave me several names of people, and all of them, obviously quite talented and capable of talking on their subject matter that they're an expert in. What I liked about the response about yourself was, when I said, what kind of things can Kay talk about? And the answer was common solder defects and how to avoid them. I love problem solution conversations, best practices for printing, the cost of rework. And the cost of rework really stuck out because, there's an old adage, which I've said on this episode before or on former episodes. We don't have time to do it right, but don't worry, we have time to do it over. So, if we could just not do it over, if we could just do it right the first time, that clearly is a preferred method of manufacturing, because people don't really realize what the cost of rework is. The cost of rework is generally many times more than the cost of production in the first place. So,
True.
So let's kind of get into the weeds a little bit. Let's start with printing, because printing comes before soldering. The very generic topic was best practices for printing. So we can go all over the world with that one. But talk to me about the printing process as you've experienced it. And in particular, in your short career at Indium, what have you seen people do incorrectly, that more than once? What are some of the common mistakes people make when they print solder paste onto an assembly or onto a board?
Yeah. So I would just backtrack a little bit to your initial analogy and kind of like past experience with
Sure.
the printing business, and just tying it back to what we're talking about now about like the common problems that I encountered during printing. The honest truth is a lot of the people who are on production lines today have a lot of experience, and they've been in the business for a very long time. And when you ask me that question, one thing that sticks out to me is we just as humans run on autopilot, and people just like have done this over and over and over and over and over again. I remember someone on the floor told me I can close my eyes and run this equipment backwards. So it's like they have so much experience. And so that can be a great thing, but it can be also a very dangerous thing, considering how delicate what we're working with is. I remember just on the floor, someone had like programmed an equipment, and it was running, and didn't realize that the squeegee pressure on the backward stroke was totally different from the squeegee pressure on the forward stroke. So it was just like, it was complaining, oh, I can't get a clean wipe. I can't get a clean wipe. You really can't get a clean wipe, not because, the paste has issues or anything, but because like, something as little as that was no one went back to check what was programmed and what was going on if someone had run a different program. And so we always encounter those kind of problems that are just like based on human errors, and not out of lack of training, but just kind of out of lack of overconfidence. So that's one thing I see a lot in the industry. Like it's little mistakes that are being made during the printing process that if we double check, or if we just kind of like follow procedure and not bring out procedures from our head, but actually go through the steps of the procedures and make sure everything is done accurately, we'll be able to eliminate some of like the common human errors we find.
Sure. I one of the things I used to do, I'm a licensed pilot, although I don't fly anymore, but
Oh wow.
in my training days, they told you to read the checklist. And I flew Cessnas. They weren't very complicated, and this was before all the modern GPS stuff. So it's all analog instruments, and you did a checklist. I also learned that pilots, commercial pilots that do this for a living on complicated planes, use a checklist. And even though you mentioned they could do it in their sleep, they could do it with their eyes closed, backwards, forwards, whatever. Even the most experienced pilot in the world reads a checklist. They're required to. They can't do it by memory. And that is to your point that, people who run one particular piece of equipment for a living, a printer, an oven, a wave solder machine, whatever, pick and place machine, they get used to the machine doing certain things. You get a mental expectation that when I push this button, this will happen.
Exactly.
And even have you ever seen those sentences that have like two thes in a row or whatever? And 90% of the people will read that sentence without noticing the error. Our brains fill in what's missing. There's probably, I'll get some expert on the show someday that can tell me exactly what that is, but our brains fill in the missing pieces because it matches our brains want to match our expectation. And I think that happens all the time in every industry, but in our industry, I think that happens all the time. I've seen it in the world I live in, the cleaning world, and I've seen it, heard it talked about in the printing world and other worlds where they just expect something to happen and something doesn't. They don't even see it. It takes someone from the outside to see it, or it takes a test later or a failure later to show it. It was there the whole time.
Yeah, I agree with you. And sometimes our expectations, like one of the ways the industry is moving, everything has to be faster. We're going towards miniaturizations, everything smaller. We want to cut costs, make everything cheaper, and all of that, and still more efficient. And so usually, just because we're trying to like decrease cycle time or to decrease cost, a lot of times we also try to use the shortcut, and that kind of circles back to the cost of real work, and you're finding all these defects or all these skips, or someone's trying to increase it and make it go so fast, and you reduce your reflow time, and just really do things that if you took your time and did it effectively the first time, you won't have as much effect, or just even did your groundwork or your research before actually running the line and making sure that everything was inspected, everything is done the right way. You will save yourself like so much more time at the end.
Right.
And just do it right the first time. Right?
Benjamin Franklin said many years ago, an ounce of prevention is worth a pound of cure. So it's probably a metric version of that too, But I think the point is that a little bit of extra work at the beginning saves a lot of extra work at the end. How important is it when a manufacturer, an OEM or a contract assembler has a new project, and they are told use lead-free solder paste with a no clean flux or a whatever, ROLO or whatever it is. How important is it for them as they reach out to their paste supplier, whether it's Indium or Kester or Alpha, whoever, AIM, whoever makes paste? How important is it for them to work with the manufacturers and consult with them and bring the product to the paste manufacturer so that the paste manufacturer can recommend the right specific paste type?
I think it's very valuable. And some things that are being qualified in the initial process, doing like a paste evaluation takes time. And a lot of people, that is time that would have been better spent doing something else according to them. But I cannot overstress how important it is to actually see what's out there in the market. Because some of the defects you will find later on, we have an extensive R&D department. I'm sure other manufacturers probably do that too, that spends time to get customers' feedback and do some research beforehand to make sure that some of these defects, we have products that can actually fit or solve the problem.
Sure.
So just speaking with like your paste supplier and finding out like, okay, these are my goals. What are the main things you want to that you cannot compromise on, and we can look for what products are out there, and also little things like how big, what are the pad sizes and the aperture sizes, and finding out what size of paste, because sometimes people overlook that and kind of like go to really smaller sizes when they don't need to. And obviously of the fact that when you use a way smaller size, like you use a type 6 instead, and you could have gone with a type 4, then you're experiencing oxidation at a type 6 level that you probably would not have had to deal with if you just kind of like did the math up front and did the work up front and worked with your supplier to make sure you got the right material for you, and the right flux vehicle, the right particle size, and all of those other good stuff.
Sure. I would imagine, like most customers, at least in our industry and our specific industry, and I'm sure yours too, when something goes wrong, it's the supplier's fault instantly.
It's the paste.
Yeah, you sold me some, Kay, what'd you do to me, Kay? You sold me some bad paste, right?
Yes.
And it had nothing to do with the fact that it wasn't kept refrigerated or it was kept beyond its expiration date or it had the wrong, size. It was type 6 instead
or
of
you
type
used
4.
it and put it back into the fridge, and we told you not to.
Right.
And you mixed old paste with new paste.
Sure.
Yeah.
Sure.
It's none of that. Or that, you didn't tell us the finish you were using for the board finish, and the paste you're using, the flux vehicle is probably not strong enough to clean off the amount of oxide that is on your component or your board and all of that stuff. We don't know about that, but it is the paste fault.
Right. Of course. Well, that's kind of stresses the importance of working with your supplier. And I think I don't know really much about the paste business from a business standpoint, but I know in our industry, one of the consumable items in our industry are cleaning chemicals. We don't make them or sell them, but other companies do. And someone will spec in a process. They'll buy our machine with, brand A chemical model 2, and everything is perfect. And then somebody talks to the buyer and they said, you're spending $55 a gallon on chemical. We can give you one for $35. It does the same thing. And they go, great. And they just buy on price because someone outbids them. And next thing you know, we're getting phone calls saying, we're leaving flux on our board, or we're getting foam, spilling onto the floor, and people are slipping and falling, or whatever the case may be. And
yes.
I'm sure in your world too, because I'm sure solder paste is considered, you wouldn't consider it a commodity. There's more science and there's more investment and energy in that product to be a commodity, but many people view it as a commodity. And I'm sure your paste, specific type of paste, that meets certain criteria, is spec'd in, and then one day, someone sells them a cheaper paste that saves them $1.50 a year, or whatever. And all of a sudden their process goes south, and then they try and figure out what went wrong. And they probably spend a lot of effort in calling the equipment manufacturers to say, my printer's not working right. And inevitably, we always find someone changed something in the process, and it was usually not where they're looking. It's usually a little further upstream. Has that been your experience where you thought everything was perfect, and then all of a sudden you get phone calls, and it's because someone made some change that maybe they changed to a different type of stencil that required one of your different pastes, or they used a different type of oven with more or less zones with whatever, and that would be better with a different type of paste, but no one let you know. Does that happen? Is that part of the real world of a solder paste salesperson?
Yes, totally. It always happens when there's always an issue that could have been avoided if the right groundwork was done, or just the right in general. Let me give you one example. Like when you're printing, like one of the first things that people overlook, but that is super important, is like making sure you have the right tooling. Because if your gasket is poor, like you have unstenciled bleeds and all this bad stuff that you don't want to happen. You have too much paste on the pad, and then you're printing way more paste, and then you have issues later. It's obviously the paste fault. But those are things that
Hmm.
you go to a customer site and you look and you just pretty much touch the stencil and you see it bouncing, and you'll be like, okay, you know what the problem is right off the bat. So just things like that, if the customer works with us, and we're always here even after you have issues as a customer. I'm sure, like, that you can always call. That's one of the value propositions at Indium Corporation. You can always call us, and we will do our best to make sure we help you. But it's always an issue, and I think it's just life in general. Like, we always run into situations where if we did our homework, we probably wouldn't be in that predicament at this point.
Sure. Let's change gears a little bit, and we'll kind of wrap up with this subject. Indium and every other solder paste company manufactures a variety of fluxes, water-soluble fluxes, rosin-based fluxes, resin-based fluxes, and no-clean fluxes. And I think, and I've said this in other episodes, all the manufacturers ought to get together and just agree, let's not call it no-clean anymore. Let's call it low residue, because a lot of people are cleaning no clean, and no clean. When Indium or any company makes a solder paste and they put no clean on the label, they're not telling people not to clean it. They don't know what the application is. Maybe it has to be cleaned, maybe it doesn't. What I think no clean, the word no clean, I think really means, if I were to retranslate it, that if your intention is not to clean a board, you need to reflow it with no clean flux. But reflowing with no clean flux does not mean you don't have to clean it or you should not clean it. It just means if you're not going to clean it, this is the right one. You certainly don't want to use an OA, a water organic acid flux, and not clean it. You don't really want to use an RMA and not clean it. But if you're not going to clean your board, definitely you have to use a no clean. But our experience in the cleaning world is that a little over half, and we're looking through a set of filters, so our numbers may not be completely accurate. But in our world, about half of all the people cleaning boards, no clean, they're cleaning about a little 50 or 60% of everything they're reflowing with a no clean solder paste. They're basically making the decision to run everything no clean and just clean what needs to be cleaned, so they don't have to keep changing fluxes, which is a sound strategy. But in your world of solder paste, do you get questions like that? Like, can I clean it? Should I clean it? Are there better fluxes to use if they're going to be cleaned? No cleans were never designed to be cleaned. They were designed to stay on. And through all sorts of technical reasons, miniaturization and introduction of lead-free and higher density components and much lower standoff heights, the amount of residue tolerance is so low now on an assembly that not so much the no clean flux residue is causing the problem, but when you don't clean the flux, you don't clean anything else off the board. So the totality of all of the residue stowaway species from board fab, component fab, humans, and then a little bit of flux residue, the totality is becoming problematic. So people are more often now cleaning again than they did before. And since no clean is like the number one most common species of flux being used, it is also the most common flux being cleaned. So how do you, when customers contact you, and ask you, do I never have to clean it? What is a response a solder paste company would give to that kind of question?
I feel like the first question I will ask is to just basically find out, if you're a contract manufacturer, like, what are the things that are already set up in your process? Like, do you have to conform or code it? Are you doing ICT testing? Are you doing probe testing on it? And those kind of things. Does your customer require you to clean it? Because those questions are more important than, do I have to clean this? Because it's no clean, the residue is manufactured to be benign, so it shouldn't have you shouldn't have as much problems with it as you will have with, let's say, like you said, an OR or stuff. But we have also seen that some for some high reliability issues, customers will rather clean it to make sure that every single inorganic acid or whatever is completely gone from the board. One thing we always say is if you're cleaning it, you should do it right because it's actually more dangerous not to clean enough than to leave it benign. Because when you start cleaning and you don't completely clean it, what you're doing is you're removing the rosin, the protection that encapsulates the
All the activators and the bad
yeah
actors,
that
right?
yeah, most of the activators have actually like escaped, but that encapsulate like the rest is just some like ions that's still there, and moisture or anything can cause dendritic growth. So what the rosin does, it keeps it together, it prevents it from moving around and getting from moving around. So when you clean, what you're doing, you're taking off the rosin that is there, and so you're actually, if you don't completely clean it, you're giving these ions more freedom to move around and cause more damage on your board. So if you're cleaning it, you should clean it right. And then the question comes with how clean is clean. And, that is another like rabbit hole that you can get into.
That's right. That's like,
But
what's the meaning of
there's so
life? It's
many.
almost as big as what's the meaning of
Yeah.
life? How clean is clean enough?
Yes, yes. So, and then it's like you don't want to over clean too because that's time and money that is
That's
being
right.
wasted. So, it's a question that is beyond asking us. I think it's very case specific. Every customer's process is completely different, and whoever the application engineer that's helping you will need to pretty much understand your entire process, the end goal, and all of that to be able to kind of like guide you in the right direction. But definitely, those are questions we would like to have and to like to help you with.
Yeah, that's good. I like the fact that the response to "Do I need to clean this?" is really the response to that are questions, not answers. They're questions. We're the same way. How clean is? Someone will ask us, "How clean is clean enough?" And I'm like, okay, well, if I have to answer that right now without the benefit of any knowledge of your product, then I'm going to have to say 0.0 micrograms of contamination is good. And someone will go, do I
And
really need a
that's
zero? I said,
almost
well,
impossible.
which is almost impossible. Well, it's possible for 5 seconds, and then you look at it and it gets dirty, right? So, but
Exactly.
unless I know what's the cost of failure, where is it going, how long is it expected to last, how close are the components to each other,
How will it be used? What's the end use of
how will
it?
it be used, who's going to use it, what's the exposure when it's being used? I'd have to ask at least a dozen questions, and then I might be able to give a quantifiable recommendation. Well, my experience is in that application, a 1.1 is better. You should be able to get away with that. But unless people ask the question and don't provide the details, so the only number I can only give one of two answers. One is it depends, which nobody likes to hear, but it's probably the most accurate answer you can give. And the other
True.
is zero, because I don't know. I don't know if it's just going to go on my chest. Is this going to keep me alive? If it's going to keep me alive, I want it to be a 0. If it's going to keep my air conditioner running, maybe I want it to be a 2. If it's going to keep my pool filtered, maybe I want it to be a 3. If it's going to, if it's going to play a song for me in my ear, maybe a 10. But it's all relative to the reliability expectation, the cost of failure, reputationally or from a litigation standpoint. If things fail, if something fails and people die, or something fails and people miss a flight, 2 different things, right? So reliability expectations are all over the map, and so are cleanliness. But I really like your point. If you're going to clean it well. A lot of people don't get that. You can actually, even further in your point, okay, you can actually make the board dirtier if you don't clean it well. Not just open up the activators and let the bad actors out of jail to cause havoc on the board, as you suggested. That is certainly a real possibility. It's also possible to make the board 100 times dirtier if you wash the board using a wash chemical additive to remove no clean or any other type of nonpolar substance, and you don't fully remove the wash solution. That board, ionically speaking, is 1,000 times dirtier than before you cleaned it. And so if you wash and didn't rinse properly, your board is definitely going to fail as a part of a bad wash process. So it is, go big or go home. It is all or nothing. And when we do workshops, I show a picture of an old man playing horseshoes. And I'm not sure if you're familiar with the fine summer picnic game of horseshoes, but it's basically, as close to the pin as possible. Whoever's the closest to the pin wins. And cleaning is not like horseshoes. It is not, well, just try, let's give it a good shot. It is all or nothing, as you said. It either works or it doesn't work.
Or it doesn't work.
Yeah. So let me ask you as you wrap up, and this is kind of a loaded question, but how do you like this? No one's listening. It's just me and you. How do you like this? How do you like this industry?
Actually, I think it cycles back to like the first question you had asked me about being new to the industry and realizing how much people already know and fresh eyes and all of that stuff. I think for me, it's super exciting and thrilling for two reasons. For the fact that I'm new and for the fact that I don't know much. So those are kind of like one and the same thing, but it opens me up to that. To first of all, it keeps me on my toes because I realized like one story I like to tell all the time is I think one of the first few months of when I started, I I think it was the first week of actually like answering like real customers questions. I got a phone call and it was on the topic that I knew well. I think it was on printing, and they were asking about paste and storage conditions and just like things that I had gone over and over and over during training. So I was like, yes, I have this. And I was excited. My first call was a success. And I had that instant gratification. And then like a few minutes later, I get another call and it was on the topic that I had no idea about. And I'm like, okay, I have to ask someone. And I was gracious enough. I took the customer's contact and then I reached back to my colleague, and I later found out that it was actually a really, really like deep and challenging question that we had to do some research on. But we always get that it's a constant mix of like, oh, I think I know what I'm doing. I'm glad I can help you, and I'm glad I'm contributing and learning at the same time. And then there are times when it's like, oh, I need to know more. So it keeps you humble, it keeps you on your toes, it keeps you learning, it keeps you excited. Every day is different. You really don't know what you're going to walk into, but it's all science, and science is cool, and no one knows the answer. And if we're honest, even people who have been here for 40, 60 years, like they get questions and get situations where it's like, I've never experienced this before. If any scientist will ask themselves questions deep enough, you're going to get to a point where you'll be like, I don't know the answer. And that's what makes it so interesting and intriguing for me personally. And it's just a good challenge. And there's no better industry right now that I would like to be in. And I actually do like my company and my coworkers a lot. Indium has great people. So it's a good way to start life. I'm excited.
Well, very good. Well, on behalf of the entire electronics industry, welcome welcome to the industry. We're glad you're
Thank
here.
you.
This has been a lot of fun. And let me just ask you one last question. Have you started a
Sure.
robotics club at Indium yet?
No, not yet. We've been thinking about it. I think you'll be my first recruit.
Well,
when are you coming over for training?
have you ever seen BattleBots where they build these robots that beat up each other?
Yes, I have seen it. But yes, I don't know if I really subscribe to it, but I have
a little
seen
too
it.
violent for you.
Yes, I rather I liked first, which is what I started at first for the inspiration of science and technology, first robotics, and it's one of the teams or kind of like the big buzzword in that space is kind of gracious professionalism, which is kind of like the reverse of battle box. And it's kind of like in first robotics you see kids because it's for high schoolers and middle schoolers, and I think some elementary schools do it too. And it's all about like sharing information on the battlefield. Like teams help each other when their robots break down. Like we do collaborations, so it's all about like
So you don't try to
sharing
kill. You
information.
don't try and kill your opponent's
No, we don't
robot.
try to. We don't
Right.
fight. We have a goal. We work individually towards it, and which is what I actually like about.
That's great. I don't know if you've ever seen online the company. I think it's Boston Scientific that plays a lot with robots, and like anatomically accurate robot, arms and legs and heads and things like that. And I've seen videos of, someone will kick the robot to try and knock the robot off its feet. And it stumbles and gets back up. I actually feel bad for the robot. Obviously, I feel like, don't kick that guy.
Sometimes they are totally destroyed. Like sometimes the robot is like gone.
Right.
And I'm like, oh my God, that's so much months of work.
Right. But see that you look at it as all the investment in time and energy and science. And I look at it as, the poor guy or girl, I don't know. Robots aren't gender specific, but I just feel bad for the thing. But yeah, you're right. If you're going to make an investment in effort and energy and science and knowledge, it's best if it's not hit over the head with a sledgehammer.
Yeah.
So
especially when it's with kids.
Right. Well, there you go. Well, I'll be looking out for the robotics program at Indium, and I'll be an honorary member from the West Coast, and we'll see if I can contribute some ideas, and we won't try and break them. We'll be good.
All right.
All right. Kay,
you're part of the team now.
Okay. All right. You heard it here first. Kay, thank you so much for joining me. It's been a joy. Thanks for a nice conversation. I really appreciate it.
All right. Thank you. Thank you for having me on your show.
Well, that's another episode. Thanks for listening to the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on iTunes, Spotify, iHeartRadio, or wherever you get your podcast. Reliability Matters and other reliability-based podcasts are available at Circuit Assembly's PCB Chat at pcbchat.com and at Ascendo Reliability at reliability.fm. Thanks for your comments. Please keep them coming. Send comments and episode suggestions to Mike at MikeConrad.com. That's Conrad with a K. Until next time, thanks for listening and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.